Alright, today we're going to be looking at our third method of solving systems. Just a reminder, we had our first method, that was graphing, and then we have our next two methods that are called algebraically. Okay? When you do something algebraically, you can either do one of two things. What we've been learning, which is elimination. And then today, we're going to be looking at our new one, called substitution. The better you are at both, the better you will be at solving harder problems. If you do them only one way, some problems are going to be really hard. So you want to try to practice both of them. So here's our new method called substitution. Let's look at a word problem. Josh buys 3 upper-level tickets and 6 floor-level tickets to the 21 Pilot concert for a grand total of $372. Tyler, he purchased 8 uppers and 2 lowers for $264. They don't know how much each tickets cost, so our task is to find the cost of each type of ticket. So remember, I told you those are usually your variables. So we've got 2 types of tickets. We've got upper levels and we've got lower level. Or no, it's floors, sorry. Upper level and floor level. The question is, what are we talking about, the number of upper level and the number of floor tickets? No, we're trying to find the cost of each type of ticket. Alright. So let's read about Josh. Josh buys 3 upper level and 6 lower level for a total $372. Well, to find my total cost, it would just be 3 times the number of upper level, or the cost of each upper level ticket. So 3 tickets times the cost of each ticket, plus 6 floor tickets times the cost of each floor ticket, for a total of $372. Tyler purchased 8 and 2. He purchased 8 uppers levels times the number of tickets, plus 2 floors times the number, or times the cost of each ticket, for a total of $264. Alright, there's nothing new there. That's all. We've been doing that for a couple days. What we've learned is we've learned to solve this by graphing them. These would be kind of hard to graph because of the big numbers. But we also learned it by solving by elimination. Today we're going to learn about solving by substitution. When you have substitution, if I have a substitute teacher, the teacher replaces me. Solve by substitution, you're going to replace a variable. To do that, we are going to solve for one of the variables. Okay, isolate. Get one of the variables by themselves. It can be any of the x's or any of the y's. You get to choose. I'm going to choose to get this guy by itself. So I'm going to subtract 8x on both sides. And I get 2y equals 264 minus 8x. And then I divide everything by 2. And I get y equals 132 minus 4x. Alright, so now I know y is equal to this. That means anywhere I see a y, I can replace it with this. So what I'm going to do is I'm going to take this guy right here and put him into wherever else I see a y. Don't put him back into the same y. Plug it into the other y, right there. So now I get this new equation, 3 times x plus 6 times y. But what is y? Y is this whole thing here, so I'm going to have to put in parentheses. 132 minus 4x. So here's 3x plus 6y equals 372. You're going to need a calculator out for these. Whenever you have a number in front of the parentheses, we like to distribute. So I'm going to bring down the 3x, and then I'm distributing this. 6 times 132 is 792. Minus 24x. After we distribute, we like to combine things. So that's going to be negative 21x plus 792. Now we can start subtracting some things over. 372 minus 792. Get negative 21x equals negative 420. Divide by negative 21. Divide by negative 21. Oops. And I get x equals 20. Just like before, to find our other variable, we take it and we plug it into anywhere we see an x and a y. I can plug it into this x, I can plug it into this x, I can plug it into this x. This one happens to be the easiest, so that's what I'm going to do, but you won't go wrong either way. Okay? So we'll go right this time. There we go. We got y equals 132 minus 4 times 20. Just type that into your calculator. You get 52. So again, you don't want to answer, you always, whenever you work on, you want to answer the question. The question is, find the cost of each type. Well, x is 20, that's the upper level. The cost of upper level tickets is $20, and the cost of lower level tickets or floor level is $52. And there's your answer. Now, whenever you have a word problem, make sure you respond in a sentence, not just x's and y's. So here we have a problem. And again, we want to do a substitution. I want to get one of the variables by themselves. I already do. I have y by itself. So I'm going to take this and I'm going to plug it into the other y. I'm going to do that. I get x plus 2 times y. Well, the y is 3x plus 2 equals 11. We like to distribute. And then after distributing, we like to combine our like terms. So here and here. So I get 7x plus 4 equals 11. Minus 4 from both sides. Divide by 7. Alright. That's the new part, right? I had a y equals and I just replaced it with the other y. Now, just like before, once I have an x equals, I have to plug it into any equation that has an x in it and a y, either this one or this one. I'm going to plug it back into this one. And when I do that, I would get y equals 3 times 1, because 1 was our x, plus 2, so y equals 5. So again, I want to check my answers. Remember, checking is an important part of making sure you did this right. To check it, I'm going to plug it into the other guy. So I got x plus 2y equals 11. Our x was 1, 2 times 5. Yeah, that's 1 plus 10. That's 11 equals 11. So I know I've got the right answer, so I'm going to write down my answer. We're trying to find where the two lines intersect without actually having to graph them. They intersect at 1, 5. That's what we just found. We're always trying to find where do they intersect. This guy's a little bit different. If you notice, he doesn't have an y equals or an x equals. This guy did. He had a y equals. This one doesn't. So I want to get one of the variables by themselves. Isolate it. Get either x on one side or y on one side. If you think about it, I could get this x by itself by just moving that over. That's actually really easy to do. If I tried to get the y by itself, I'd have to move this over and divide by 2. So that's a couple steps. So I'm just going to get that x by itself, and I'm going to do that by subtracting 2y on both sides. So I get x equals negative 6 minus 2y. Well, this guy right here is equal to x, so I can replace him where I see an x. And I see an x right there. So I've got 4 times x. X is negative 6 minus 2y. And then I got to finish my equation. Plus 6y equals 4. We like to distribute. We like to combine our like terms. And then we finish solving. Divide both sides by negative 2. But again, once I found that my y, I have to plug it in to find my x. I can plug the y into here, I can plug it into here, or I can plug it into here. I'm going to go here. Let's go there. So I would get x equals negative 6 minus 2 times our y. Just type that into your calculator. Negative 6. Got 22. Those slightly big numbers, maybe you're kind of like, is that correct? Maybe I don't know. So what we do is we always like to check it. Right? So it doesn't matter. I plugged them into this guy. I'm going to plug them into this one here. 4x plus 6y equals 4. I always like, when I'm checking my answer, I always like to plug it back into the originals. Okay? So 4 times x plus 6 times y equals 4. And you just type that in. But I didn't get the same answer. 88. Let's see if we made a mistake. Oh. Yeah. Here's our mistake. My mistake anyway. My y value was negative 14. So now I type this into my calculator. And I get 4 equals 4. And I feel good about that. So I know that the graphs intersect at the point 22, negative 14. And there's my answer. Come up with your own organizational schemes when you're doing this. I know I've been drawing a lot of arrows and using colors, but you can find your own organization as well. Alright, y equals negative 3x minus 7, y equals half x. Remember, our goal has always been to get an x equals or a y equals. Always try to get a variable all by itself. In this case, I already have a variable all by itself. It's right here. So this whole thing can go into the other y. Well, where's the other y? It's right here. So I'm just going to take this y, instead of writing the letter y, I'm going to write down what y is equal to. So I get negative 3x minus 7, that's this part, equals half x. Now I've got just x's, so I have to solve it. Lots of ways you can solve it. Some of you might add 3x to both sides. Some of you might multiply by 2 to get rid of all of the fractions. So I'm going to go ahead and just multiply everything by 2 to get rid of the fractions. That gives me negative 6x minus 14 equals 1x. Because 1/2 times 2 is 1. And then I'm going to add 6x. Negative 14 equals 7x. Divide by 7, and I get negative 2 equals x. Now again, what do we want to do with this x? We need to plug it in somewhere. So I'm going to take it, and I'm going to plug it into, it doesn't matter which one, we'll go this one. Just always plug it into one of the originals. Or not one of the originals, anything that has an x and a y. So I got y equals 1/2 times x. That's negative 1. So right now I'm saying that they intersect at the point negative 2, negative 1, but we always want to check it. So I'm going to plug it into the other guy that I haven't used yet. It's negative 1 equals negative 3 times negative 2 minus 7. It's negative 1 equals negative 1, so it works. So I know my answer is right. Alright. I want you to try this one. Remember, your first step is to pick one of the variables and get it by itself. You can try to get it into x equals or into y equals form. It's up to you, but go ahead and pause the video and start the problem now. Alright, here is the answer. It's negative 1, 3. That's where the two graphs would intersect if we were to graph them. If you got that, great. Go ahead and move on to the summary. If you didn't, you can try to follow my steps here, or if you want to, if you did something differently, for example, I solved for this y right here, but you could have solved for this x, or this y. If you did something differently than I did, show us in class the next day, and I'll try to find where you could have gone wrong. Alright, your summary question. What are the steps to solving a system by substitution? So think about this one. What kind of steps would you use? Go ahead and write these down somewhere. Are there any steps that are similar in substitution and elimination? And which variable should you solve for in your first step when performing substitution?